All right, in this video lesson, we're looking at balancing chemical equations, and I'm hoping to teach you a strategy that you can use to balance chemical equations every time you need to balance an equation. So sometimes when you need to get a chemical equation, you're given what the compounds are that are involved. You know what they are, so you know the reactants, you know the products, and you just need to make sure that the coefficients are resulting in the same number of each type of atom on the reactant side and the product side. Sometimes you're just given the reactants and you have to use what you know about types of equations to predict the products. So we're going to walk through a few examples where you are given just what is involved, and you need to go kind of from what is involved to a balanced chemical equation. So remember, just as we get started, that a balanced chemical equation is when the number and type of each atom is the same on both sides of the equation. So in our first reaction, we are looking at magnesium and oxygen. And what we want to do is start by writing out a word equation. So again, I'm showing you the full, all of the steps. You will get to the point where you could probably just write out the skeleton equation using the symbols. So our word equation is, oh, that's really thick. So our word equation is going to be magnesium plus oxygen, and then we use our arrow to say reacts to produce. And then we kind of have to think about what our products are going to be. And in this instant, we have two elements. When we have two elements, we know that they're going to probably react together to make a compound. And so in this one, we are going to get magnesium oxide, because we know from our nomenclature, magnesium and oxygen bonding together are going to make magnesium oxide. Then we write out our skeleton equation using chemical symbols. So all that is writing out our symbols for everything involved. So Mg, we know magnesium is a solid. And oxygen is O2. It's found as a diatomic, so it's found as a gas. And then we write our arrow and we do our crisscross and we get magnesium oxide is MgO. Okay. So at this point, we have to see if our number of each type of atom is the same on each side of the equation. So what I like to do is draw a little line, and I count the number of each type. So I know I have magnesium on both sides, and I have oxygen on both sides. And if I look, remember that the right here, when there's nothing here, it means there's a 1. So that means that we have 1 magnesium. And we also have right here another invisible 1, but there's 1 O2. So that means that there's actually 2 oxygen atoms on our reactant side. So I'm just going to get rid of these. And we do the same thing on the other side. And so when we look, we have 1 magnesium and 1 oxygen. So now I have to see if the number and types are equal, because they have to be equal. You cannot create or make different atoms disappear. So what a quick check is showing us that there's 1 magnesium on the reactant side and 1 magnesium on the product side. So I put a little check mark there to say that they're equal. It's balanced. But in my oxygens, I have 2 oxygens on my reactant side, but only 1 in my product side. So this gets a big old X. So now we have to go through some steps to make it so that each type of our atom is equal. What we can only do, the only thing we can do is add coefficients. So those coefficients are the numbers that are in front of the formula. We are not allowed to change any subscript numbers. And so here are my rules. Always start with elements that occur only once on each side. Now this one's a very easy example, so they both only occur once. Leave any substances appearing as elements until close to the end, because they can be balanced very easily without affecting any other atom. And then the other trick is to leave oxygen and hydrogen until the end. Usually, if you balance everything else out, the oxygen and hydrogens end up getting balanced. When I start multiplying or adding coefficients, you always have to keep checking to make sure everything else is balanced. My hint said leave oxygen till the end, but in this example, oxygen is the only one I need to fix. So to do that, because I have 2 oxygens on my reactant side, and I only have 1 on my product side, to make it equal, I can multiply this side by 2. By doing that, it now says I have 2 MgOs. So that means I have 2 magnesiums and I have 2 oxygens. So I do a little checkpoint. All right, my oxygens are balanced, but now my magnesiums are not balanced. So now I have to balance my magnesium. And this is fairly easy example because I have 2 magnesiums in my product side now, but only 1 in my reactant side. So if I had a 2 here, this becomes a 2. That green 2 only impacts magnesium. And so now my magnesium is equal and my oxygens are equal. So if we just write out what we did down here, we took the magnesium oxide and I multiplied it by 2. And then in green, I took my solid magnesium and I multiplied it by 2. Then our last step is common factor if you are able. So this means that you have coefficients that can be reduced and put into lowest terms. Now, our oxygen gas has a coefficient of 1. So the whole thing is already in lowest terms. You can only common factor if you can reduce every single coefficient. So for this example, we do not need to call it common factor, and our balanced chemical equation looks like it's 2 Mg solid plus O2 gas makes 2 MgO. Okay, so that's our first example. Let's look at another example. Example number 2. I'm just going to make a quick correction here. Methane is actually CH4. So we're going to look at methane gas. It burns in oxygen to produce carbon dioxide and water. So in this example, it is giving you your all of your reactants and your products. Sometimes you'll be asked to write a word equation. And so to do that, we're going to do that for step 1. Write our word equation. Methane plus oxygen makes carbon dioxide plus water. Our second step was to write out our skeleton equation. So this is just putting in chemical formulas instead of the words. So methane, CH4, plus oxygen. Oxygen's always found as O2, plus carbon dioxide, CO2, plus water, H2O. Excuse me. All right, so now we have to count up our number and type of atoms on each side of our equation. So I'm going to draw my dashed line here. And I'm going to start with carbon. And I've got hydrogens and I've got oxygens. Okay, so carbons, hydrogens, oxygens. On my reactants side, it appears to me that I have 1 carbon. I have 4 hydrogens because the 4 down here beside the hydrogen means that there's 4 hydrogen atoms in that compound, and I have 2 oxygens. On my product side, it looks like I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens. So we do a little check. So carbon is added up, hydrogen not adding up, and oxygen not adding up. So remember our rules. Our rules were leave oxygen and hydrogen till the end. Looks like we have no choice because carbon is already balanced out. And it also said that leave substances that occur, start with elements that only occur once on each side. So if we look, hydrogen is only occurring once on each side. Hydrogen occurs twice in our product side. So we're going to start with hydrogen. I have 4 hydrogens on my reactants. And so in my products, I'm going to multiply my water right here. I'm going to put a 2 right here in front of the water because now I have 2 times 2 hydrogens. So now I have 4. But I also have changed my number of oxygens. I had 3, but now I have 4 of those as well because the 2 waters means I have 2 oxygens. So we double check if things are lining up. Carbon we didn't do anything to, so it's still the same. Looks like our hydrogens are equal now, but our oxygens are not equal. So we have to do something about our oxygens. So we start looking. We have 4 oxygens on our product side, but only 2 in our reactant side. That's an easy fix because if I put a 2 right here, I now have 4 oxygens because I have 2 O2 molecules. So we do a check. Carbons, I didn't change anything, so it's still good. Hydrogens, I didn't change, so it's still good. And now my oxygens are all looking good. So once you have checks for everything, it means that you have that equation balanced. Step 5 was to common factor. It looks like we cannot common factor because of the invisible 1 coefficient in front of the methane and the carbon dioxide. And then we can just write out our nice equation here, CH4 plus 2O2 makes CO2 plus 2 H2O. Okay, we'll do one more example together. Now, you're not always going to have to do all of these steps. Sometimes you might be given the skeleton equation to balance, or sometimes you're given the word equation and you have to go from the word equation, so step 1, down to step 6. So our last example for this lesson, zinc metal reacts in silver nitrate to produce zinc nitrate and silver metal. So step 1 was word equation. So zinc plus silver nitrate produces zinc nitrate plus silver. All right, so this is where that nomenclature that we practiced came into place. I want you to take a minute. I want you to hit pause, and I want you to get the formulas for the 4 things here. All right, so let's see if you did it right. Zinc plus silver nitrate is AgNO3. Arrow means reacts to produce. Your zinc nitrate should be Zn bracket NO3 bracket 2 plus silver is Ag. So now I want you So one thing that I hadn't talked about yet is the fact that if your polyatomic, so I'm going to circle my polyatomic in blue here. If your polyatomic ion, like nitrate, NO3 and NO3, stays connected, so it stays as exactly the same polyatomic, you can consider that as one thing down here. You don't have to separate it into the nitrogen and the oxygen. It actually makes it a little bit easier for you to do that. So if you've added up your number and types of atoms, you have 1 zinc, 1 silver, 1 nitrate in your reactants. You have 1 zinc, 1 silver, and 2 nitrates in your products. So we do our quick little check. Zinc lines up, silver lines up, nitrate does not line up. So to fix that, we need 2 in our reactant side. So we're going to put a 2 in front of this one. So that means that we now have 2 silvers and 2 nitrates. So our zinc we didn't do anything to. Our silver does not line up anymore, but our nitrates are now equal. So now we have to fix our silver. Silver appears as an element on the product side. So to make it all equal, I just have to multiply it by 2. Did nothing to zinc. Our silver lines up. Our nitrates line up. So once everything has a check mark, we're balanced. We cannot common factor. And then we can just write out our nice equation here. Zinc plus 2 AgNO3 plus zinc NO3 plus 2 Ag. Okay, so this is a strategy that I find really, really helps when we're trying to balance chemical equations. Again, you won't have to do all of the steps all the time. Sometimes you're given the skeleton equation and you just have to figure out the coefficients. So then you're just really looking at doing steps 3 and steps 4. Okay, so you're going to be given some practice. I'm going to suggest you do that practice until you become very comfortable in your ability to balance our chemical equations.